Alright guys, today we're going to do some applications and focus on law of sines. This first setup is we're going to go over the area of a triangle. Now of course since elementary we've been learning the area of a triangle is 1/2 base times height. And in secondary 3 we learned that if it's not a right triangle that we could actually do 1/2 side times side sine of that angle in between. Okay, so that's why there are 3 different equations. Oh, really they're different, but they are the same because it depends on what angle we're looking at and what sides we have. Okay, so last year when we did this, we right away gave you what you needed, but in example 1 here we're going to find out we're missing a piece. So it says find the area of the triangle at which alpha is 120, beta is 45, and a is 7. So first of all, if you look, we have side A and we have alpha. Okay, so we have beta. Okay, so of course I'm going to use the one that has side A in it, so I'm here or here. Okay, and then as you can see in this one here I need gamma. Well, I have to do an extra step to get gamma, so you could use that if you want, but I'm actually going to use this 1/2 a times c sine of beta because I have 2 pieces of information there that I can get. So I'm going to write that down. I have A for area equals 1/2. Side A is 7. Side C, we're not given side C, so I'm going to just put down C right now. Sine of alpha is, let's see, alpha is 120. Okay, so we are trying to find A, so that means we're missing C. So we have to do an extra step here, and what we're going to do is use law of sines to figure that out. Okay, now law of sines means that we need a pair. Okay, so we're using the pair alpha and A, and we need to find C. Well, to find C we also need gamma, so we do need to solve for gamma. Okay, how would we solve for gamma? Well, if we get 2 angles to find the third, you subtract everything from 180, so that leaves us with 15 degrees. So now I'm going to use my law of sines. I want to find C. Remember from last lesson I said put your unknown on top. Sine always goes with your angle, so C over sine of gamma, so 15, equals, and then we use our pair, which is our A over sine of alpha. Now we could go through all this and estimate or round in the middle of the answer and then use C, but I don't want to do that. I just want to make sure these decimals are correct. So if I were to rearrange this, I get C equals 7 times sine of 15 all over sine of 120. And now I can plug that in to my equation. So I have area is 1/2 times 7 times 7 sine 15 all over sine 120 times sine. Oh, and look guys, I messed up, didn't I? I look and see, and this is very important. This is why I don't mind messing up right here. If I put this back up, it would be A times C sine of alpha. But what did I actually need to put there? I needed to put sine of beta. So luckily this was a two-step problem, because I would have messed up and not noticed my mistake. There we go. That looks way better. So sine of beta, which is 45. Everybody see what my mistake was? Okay, I said 1/2 a times c sine of alpha. You got to remember it's the angle in between, so it has to be beta. Now, when I plug that into my calculator, so guys, when you plug this in, don't forget your calculator needs to be in degrees, and then we can round that, and I'm going to round it to the second decimal place, so it's going to be 5.18. And of course, we had units there. We would do units squared because this is area. Alright, the more we study trigonometric applications, the more we discover the applications are countless. Some are flat diagram type solutions, but many applications in calculus, engineering, and physics involve 3D dimensions and motions. Example 2 here. Suppose two radar stations located 20 miles apart detect an aircraft between them. Alright, so instead of me reading the whole thing first, I'm actually going to start drawing. So I'm going to have Tower 1, the first station. So I'll put that as S1, so I know that correctly. And we have Station 2. Okay. And they are 20 miles apart. The angle of elevation measured by the first station. Remember, angle of elevation means that it's the angle from that ground. So 15 degrees. Whereas the angle of elevation measured by the second angle is 35. Find the altitude of the aircraft. So this is the aircraft, right? This is our plane. Whatever, I'm terrible at drawing, right? Now, altitude. What does altitude mean? Well, if you remember, altitude is your height, which is straight down. Well, if this were to be straight down, what are these angles right here? They are 90 degrees. Okay. Well, when I think of 90 degrees, I should automatically think of right triangle trigonometry, which is SOHCAHTOA, all that stuff, okay? So our goal right now, and I'm going to put it in purple so I remember what the outcome is we need to find this height right here, okay? But if you look, if I look at that small triangle, I only have two pieces of information. I only have that 35 degrees and that missing angle. So I can't do anything with that. I have no idea how this 20 is broken up. If I look at this triangle, again, I have 15 and that missing side. So I can't just do right triangle trig right now. Actually, this is another two-step problem. We are going to have to use law of sines to find another missing side and then use right triangle trig. Now you could do this, I'm going to do this a certain way, but you could do this a different way. I'm going to actually, I like that small triangle a little bit better, so I'm going to use that for my right triangle trig. So really what I'm missing is I'm missing this base and this side length. Well, which one of these looks more optimal for us to solve for? Hopefully you said this full side length. And I'm going to label that Y right now. The reason why is because if I label that Y, now I can use law of sines to solve for that full triangle, to solve for that side. if you wanted to use this triangle, you would solve for this side. Either way would work. Okay? So, if I need y, so I'm going to set up to solve for that side. So I get y over, remember it's what you want, over, and it's going to be sine of the angle, which of course in this case is 15. Remember, the side lengths and the angles across from each other are pairs. And then equals, well, I need another pair, right? Well, 35 is an angle we have, but I don't have that other side. I have 20, right? So I want to use that 20, but if I use the 20, that means I need the angle that is opposite of it, right over here. Well, I can find that angle, can't I? Because all three of these should add up to 180 degrees. So this angle right here is 130. And now we can solve for that side. So when we do this, we get y equals 20 sine 15 all over sine 130. Yes, I could do that in my calculator now and round it up, but just in case I don't want to take any chances, we can now have this here. So if you look at this small triangle, and I'm going to rewrite it on the side, we have 35 as the angle of elevation. We are trying to find x. Y is this 20 sine of 15 all over sine of 130. So if we look, now we can use our right triangle trig, right? We have 35, so we're going to use this angle. And as you can see, we need to find the opposite. And we have the hypotenuse. So what trig function is opposite over hypotenuse? Well, that is sine. So I can say sine of 35 equals x all over this hypotenuse Now, luckily, the unknown is on top, because how do I get the unknown, the x, all by itself? Well, I have to multiply both sides. So let me show you what you're going to put in your calculator. So we're going to say x equals, it's going to be sine of 35 times that 20 sine 15 all over sine of 130. Now, because we have multiplication and division in this, guys, when you plug this into your calculator, put an extra set of parentheses right there, so we know that multiplication comes first. So x is approximately 3.9, and then of course we are in miles. Okay. Guys, we are in upper level math here, so we want to think that we might not be able to do all this in one step, so you have to kind of plan your steps ahead of time. Okay, next page. Sasquatch Island lies off the coast of Ipswich Lake. I don't know, whoever made this question. 2 sightings taken 5 miles apart are made to the island. So of course I am going to talk about this. Remember that we are on a shore and we're looking at an island somewhere. So we have a sighting, 2 sightings, right? We have sighting 1 and sighting 2 that are 5 miles apart. The angle between the shore and the island at the first observation is 30 degrees. Okay, so I'm going to try to make that look decent. The angle, and at the second is 45. Okay, now here's where I get a little confused on why they draw it a certain way. Because I was tempted the first time to draw it like this. Okay, like 45 would probably be there. So let's read the rest of the question to see if we can tell why it's not going to be on there, because the picture that they drew and I found was that it's actually this way, guys. Okay, so let's read that again. The angle between the shore and the island of the first observation is 30 degrees, and at the second point is 45. Assuming a straight coastline, find the distance from the second observation to the island. What point on the shore is closest to the island? How far is the island from this point? Okay, I can't even see, but I'm going to go along with it, see if I can look something else up with it. Maybe it's because the 30, the 45 doesn't create, oh, I might know what it is, guys. Because if we put the 45 here, right, remember the angles and the side lengths across have to match each other, correct? So if I put the 45 right here, that would make this angle, let's see, what's 180 minus 45 minus 30? That would make that angle up here where the island is 105. Well, remember, that's the largest angle, so across from it must be the longest side. Well, if this is only 5 miles, that means both of these would be shorter than 5 miles. That kind of makes no sense for an island to be less than 5 miles if we're looking at it from an observation deck. So our island's going to be out here. So let's make that 45. And let's extend that. Of course, my line's not going to be straight anymore, right? Okay. Now this makes a little bit more sense because this is no longer the bigger angle. So these two sides have to be longer than 5, which makes sense for an island. If I had more space, I'd probably put a palm tree up there or something. Okay, so we have to do a couple things. We have to find what the find the distance of the second observation from the island. So I'm going to label that as X. Okay, because that's what we're trying to find there. But if you look, guys, it says what point on the shoreline is closest. How far is the island from this point? What point on the shoreline? Okay, we'll talk about that after we do X, because of course that's our second part. Now, alright, so since this is a non-right triangle right now, we're going to use law of sines. That was the whole idea of this lesson, was law of sines. But as you can see, I have this outside angle here. Well, how does that help us? We need the inside stuff, right? Because we have our pair right here, which is going to be X over sine 30. And we have our side length of 5. But I need that angle up there. I need this angle up here, and to only find this angle up here, I need this angle down here. Well, how can I find this angle down here? Well, these two angles should add up to what, guys? They should add up to 180 because this is a straight line. And the definition of a straight line is 180 degrees. So 180 minus 45 is 135. And then 135 plus 30 is 165, leaving this angle of 15. Makes more sense when drawing that out. Okay, so this is going to be sine of 15. Alright, when we solve this out, we get x equals 5 sine 30 over sine 15. When we plug that into our calculator, we'll get 9.66 miles. Great. Let's move on to that second part of the question. On what point of the shoreline is the closest to the island? So guys, this is not a mathematical question. This is actually asking you, where would it be? Well, think of this. When we do the shortest distance to anything, the shortest distance is going to be when you go straight there. So I'm going straight to the shoreline, which created a what, guys? It created a 90-degree angle. So your shortest is that 90-degree angle. And what do you know? Now we can answer the last question. How far is the island from this point? So we are looking at solving for y. Now this is the right triangle, so we can use our right triangle trick just like we did in the other examples, okay? So we have 45 we're looking at. We're finding out y, which is the opposite, and we are finding out, or we have the hypotenuse. So opposite and hypotenuse again is sine. So I say sine of 45 equals y all over. Now, if you want, guys, put in the 9.66. You'll find that it does come out correct. Or put in the 5 sine 30, sine 15 if you want to be specific. And then we find out that we have 6.833 miles. Because, of course, we're going to multiply the sine of 45 times 9.66. Alright, just some vocabulary at the end, and I'm going to go over this. Grade. So when you see a problem that has grade in it, the grade of a road is much like the pitch of a roof in that it expresses the ratio of rise over run. In the case of a road, this ratio is always positive because it's measured going uphill and is usually measured as a percent. For an example, a road that rises 7 feet for every 100 feet horizontally. So remember, rise comes first, run is second. So in your problems, it probably won't say this horizontal, guys. So anytime you see grade, it's going to be your rise first and then your run. 100 feet of forward process is said to have a 7% grade. However, if we want to apply any trigonometry to a story problem involving roads going uphill or downhill, we need to view the grade as an angle with respect of the horizontal. Okay, so that's just making you draw out your triangle. Okay. Bearings. Hopefully you guys had some practice with this last year. So a bearing is the direction you're heading according to the compass. However, the angle is not given in standard position as we are used to. A bearing given as an acute angle of rotation to east or to the west away from north or south. For example, north 40 degree east. Okay, so I'm going to show you on here. North 40 degree east is a bearing which is rotated 40 degrees clockwise from due north. Because it said north, we're going to start on north, and then we're going to the east. The east is toward the right, and it's going to be 40 degrees. Okay, so see how that looked to 40 degrees right there? It's not from the x-axis, guys. If we imagine standing on the origin of the Cartesian plane, this bearing would have us heading into quadrant 1 along the terminal side. So that means our angle right here would actually be 50 degrees. Okay. Similarly, south 50 degrees west. We look at south, right? We're starting at south. We're going to the west. So I'm going to go to the left, and this is going to be 50 degrees. Okay, so always start at the first one and go in that direction. Counterclockwise rotations would be found in the bearings north 60 degrees west. But again, we're looking at, we start north, we go to the west, which is left, and then we create that 60 degrees. So guys, this is just for you to know any vocabulary that you might run into problems. Alright, go to Canvas and you can start your homework.